So today we're going to be talking about hypothesis testing for proportions, and we're going to pick up where we left off. This is again on a single population, but now it's not the mean, it's a proportion. Okay. So let's jump right into it off the deep end, and let's consider this example. A company that produces parts is required to have a defective rate for parts of 5% or less. Okay. A quality control engineer believes that the company is in violation of this industry standard. So to test this claim, a random sample of 250 parts are inspected, and it is found that the sample proportion of defectives is 6%. State the null and alternative hypothesis and test the claim at the 5% level of significance. Okay. So first, let's get started with the null and the alternative. The null is a statement of equality. And so here is going to be that the proportion, the population proportion, the rate at which the company produces defective parts is 5%. The engineer believes that there's a violation of this, and violating this would mean that the proportion is more than 5%. So we have a greater than alternative. But now we're not testing means, we're testing proportions. Okay? And we're testing population proportions. The thing that indicates between the null and the alternative is the sample proportion of the 250 parts. So you inspect 250 parts and you record if it's defective or not. So notice this is a categorical setting, defective or not. Okay. And they came up with 6%. So now let's write down everything we've discussed and that's in this problem. Okay. So here, our null hypothesis, that's 5%. The alternative is that's in violation, it's greater than 5%. The information that we have is that we have a sample of 250 and that the sample proportion is 0.06. So the question is 0.06 is 6% as a sample. Is that enough data to indicate that the population proportion is greater than 5%, or is that just a bad sample? Okay. Well, let's calculate the p-value and the probability of a type 1 error. And to do that, we're going to use our normal approximation. So we can use a normal approximation if n times p times 1 minus p is at least 10. And here we plugged in the numbers, 250 times 0.05 times 1 minus 0.05 is 11. So we're good. Okay, so we can safely proceed to use the central limit theorem, okay, for sample proportions. Okay, and we conclude that the sample proportion is approximately normally distributed with mean p0, that's the population proportion under the null. So p0, you're probably wondering what that represents. That's the probability according to the null hypothesis. That's 0.05, okay, in this example. Okay. And the standard deviation is given by this quantity, the square root of p0 times 1 minus p0 divided by n. Okay. And so this is one important thing to note. p0 is the value of p given by the null hypothesis. And the reason why we're using the value given by the null hypothesis because we're calculating a type 1 error, which assumes that the null hypothesis is true. What are the chances of observing your data if the null hypothesis, the sample proportion, is indeed 5%? Okay. So we're going to use the p-value method. Okay. And we know from the alternative hypothesis that we have a right-tailed test. That is, evidence in favor of the alternative hypothesis is if the sample proportion is larger than 5%. And we need to determine if it's large enough with a probability, a p-value. So we're going to calculate the probability we observe a sample average of 6% or greater. This greater then comes from the alternative hypothesis. We calculate this probability by taking a z-score. I subtract the mean, which is p0, the value of p under the null hypothesis, and I divide by the standard error, which is this p0 times 1 minus p0 over n. And we calculate this value right here. Okay. So we calculate that value. That works out to be 0.725, and I want to calculate the probability a standard normal is bigger than 0.725. Okay, that works out to be 72%. That's greater than 5%. So this says it's very likely that we would observe this data under the null hypothesis, and we would fail to reject the null. Now let's determine how we calculated this 0.72. Okay. So we go to our online stats calculator and we go to our normal distribution. We have a standard normal, a z distribution. So mean 0, standard deviation 1. We want it to be above 0.72. Okay. 725, I apologize. And we calculate this. We get 0.23, so I apologize. Okay. This should be 0.23. And this should be 23% approximately. But that is still bigger than 5%, so we still fail to reject the null hypothesis. Okay. So that is the correct p-value, is 23%. Okay. Okay, let's do another example. And it says an experimental drug is developed, and the proportions of individuals that experience side effects must be less than 2% to proceed to the next stage. To test this contention, at the 5% level of significance, the drug is administered to 550 randomly selected individuals, and in end, it's observed in the sample 4 individuals experience side effects. Okay, so let's go ahead and write down our null and our alternative. Our null is that it is 2%, that the proportion of individuals experiencing side effects is 2%. What we want to establish is that this proportion is less. So the alternative is that it's less than 2%. We have a sample of 550. And we have observed 4 individuals who experience side effects. So you might wonder, well, what is the sample proportion? We're only told that 4 individuals experience side effects. Well, the sample proportion is the 4 out of 550. Okay. So let's record all of this information. Our null is 2% versus the alternative that's less. We can name the variables. So we have our sample size, and this is our sample proportion. That's the 4 out of 550. So it looks like our sample proportion is 0.007 or 0.72%. And we want to test this with an alpha, a significance level of 5%. So let's check that we can use the normal approximation from the central limit theorem, and we take the probability of 0.02 from the null hypothesis, we multiply that by n, that's the 550 times 0.02 times 1 minus p is right here, and we get 10.78. So we can go ahead and proceed to test the hypothesis using the central limit theorem. Now, and if we're going to calculate a probability with the normal distribution, we need to know the standard error, and it's given by this quantity. Okay. So let's go ahead and do that. We are going to calculate that we observe a sample proportion that's less than what we actually observe. And this less than comes from the alternative hypothesis. So now I'm calculating a probability with a normal distribution because I use the normal approximation. So I subtract the null value of the probability, which is the mean, that's p0, which is 0.02. and I divide by the standard error, which is this thing right here. Okay, just the denominator though. Okay, and I get that, apologize, this should be a less than. I need to calculate the probability of standard normal is less than 2.13, so let's go ahead and do that. So I'm going to leave this just like before, 0 and 1, and I want it to be below minus 2.13. Okay, and we're going to get 0.0166. Okay, I have 0.0165, it's close enough. I used a different calculator to calculate this, and that is less than 5%, 0.05. So based on the p-value, we reject the null hypothesis. Okay, and this is basically the setup of hypothesis tests for proportions, for population proportions. Thank you very much.